We saw some dirtbag trying to have a private moment of sleaziness. In nature, you know, yeah, you win some, you lose some. What else? We saw... Oh, the salmon improvements. Remember that canal would be impassable to salmon if it had a smooth bottom. Because when the water's rushing, there's no place to rest. And when the water is low, there are no pools for the salmon to stay in. There are a lot of salmon in the ocean, and we have a few that come up Mission Creek. That's an endangered run. But they exist. They spend most of the year out in the ocean, swimming around. In the fall, they come up closer to the coast. In the winter, they wait for the rush of water to come out of the rivers to charge upriver, lay their eggs, and all salmon of the world die after laying eggs except for steelhead. Steelhead are the southernmost salmon species, I believe, in North America. I think. And if that's true, that helps explain why they are the only salmon species that can go upriver, and if they don't get to lay their eggs, they can make a U-ey and come back down. All other salmon will die at the top, at the headwaters, where they lay their eggs. But steelhead can make a U-turn if they don't get to lay their eggs. They'll come trying to get another year. We went down to the beach. We saw wetlands. We talked about wetlands. Had a little break. Did you guys notice that I accidentally fell asleep? I'm sorry to go off duty.
On the beach?
Yeah, I was drying off after I went swimming, and I just wanted to take a quick second to dry out, and I woke up 35 minutes later. And I'm sorry that you were unsupervised for 30 minutes. I couldn't say that on the internet. Change the subject. Then we had a little walkie-walk, and we went to go look at some native plants and some bioswale over at the park. We did a little wrap-up review talk. And those natives that we collected seeds from, we'll be planting those seeds tomorrow in my zero period class. You're all invited to come help with that. Those are going to be for habitat restoration, so we can try to spread that sort of native goodness as much around town as possible. Jack, do you have your hand up?
Yeah, so steelhead fishing is anywhere, whatever, in the river, right?
In the river, no.
No, not. You can't.
Not in these rivers.
Oh, really?
Because these are endangered runs.
Not that that's dirt, I believe.
Oh, sorry, illegal. Yes, yeah. Illegal. Not allowed to fish in the river.
In the ocean? You can't, or what?
It's a regulated fishery, and steelhead in particular is kind of hit or miss. Steelhead is one where the government has to really hold back fishing to try to recover populations. So there's little pockets of steelhead that are big season, big numbers. There's a few rivers that have plenty of steelhead to spare. But in most rivers, in most parts of the ocean, in most ocean fisheries, steelhead is highly regulated and not much allowed. Plus, steelhead's not a really sought-after salmon. It has a very small market anyway. Compared to Chinook or something, which is an abundant northern salmon, there are tonnage of those fished every year. Steelhead's kind of a nothing. They farm a lot of steelhead. It's easy to farm, but it's not really a common ocean species. Is there anything you can tell me about salmon?
You won't find them here. There's no way.
Yeah, never find them in the ocean, right? Yeah. The ones that you get here are usually king, right? Chinook. Do you guys ever get salmon? All right. Anybody want to talk more about the field trip? I want to thank you guys. That went really smoothly yesterday. This has been my best year for field trips ever, except for Julius Aldermondo, who will forever be the butt of all jokes. Yeah, plenty. Okay. So I want everybody to look at their study goals because we did everything up until number 21. We skipped a couple that we're doing today. Hold on, but yeah. We did 1 to 21. Skipped 22 and 23. We did 24, skipped 25. Did a couple more, skipped a bunch, did number 34 and 35. So I'd like to start by filling in some of that skipped material. Today we're going to do numbers 22 and 23. Please look up. In number 23, sorry, number 22, did we already talk about how to build a dam? No? Are we all ready to fire off with number 22? Imagine I'd like to build a dam right here. This is my dam. But right now I'm in a river and you are the flowing water. So I'm holding my breath, fighting the current. Okay. And when we build the dam, the idea is to plug the river so that the water level rises, building what's called a reservoir. Then release the water from the reservoir to spin a turbine to make electricity before it returns back downriver. So you're upriver, I'm downriver. Okay? This is a top view. We want to make that big reservoir on the right, hold it with a dam that's shaped like a lens to distribute the force to the edges. If you make it square, then it just bulges in the middle. Does you understand that? You put tunnels around the edges so you can get rid of your extra water, and also, you see those little combs? Those are little tunnels. You see those little red spots? They look like match heads. Those little red spots at the end of those little comb pieces, those are the turbines that make the electricity before the water's returned to the river and keeps flowing down. Step number 1, you build a diversion canal. You just drill a hole in the side of the cliff like this. The idea of the diversion canal is to let the incoming water go around the construction site. So once I have the canal, I say, okay guys, drop the dirt, and they drop some dirt in here, and on this side they drop dirt right here. So watch me. The incoming water hits this pile of dirt, rises a little bit, and goes around the construction site through the canal. Does that make sense? The diversion tunnel comes back out here and goes down river. So I've built a little dry spot. I divert the water around the construction site to make a dry space in the bottom of the river. Yes, William?
Isn't it cheaper to just build whatever you're going to build, like the entire thing, in the diversion canal, and then just block this off and then you're done? You know, like you wouldn't have to reopen this area because you already built it.
I think it's a question of scale, though. Block this off, that's the dam. How are you going to build a dam if there's water flowing here?
Yeah, no, I'm saying like, okay.
What? No, I'm listening.
So like you divert the water, or no, you build your dam in that canal while there's no water there, and there's never been any water there. and then you put dirt here, and then it just goes into that dam.
But then what's that going to clog? The water in the tunnel?
Like, you wouldn't-
You're going to clog the river to fill the canyon with water.
okay.
This is the canyon. Watch. I think your scales are off a little bit. Once you have that dry space on the bottom, then you can start building. Pile of dirt, put the concrete on it, more concrete, more concrete, more concrete. Get some little bits of plumbing. And put your valves that control the water dynamics through the dam. You build the fill towers. So these are like overflows, so they take the surface water and it fills in. Like that. Overflow columns. Build your electrical generators down below. And there you go. You've built a dam. You can now drive across the top and wave your American flag and enjoy. I think that's Hoover Dam. Yeah. Enjoy Hoover Dam.
Where is that?
Near Vegas?
The wildlife inside the canyon kind of drowns it, right?
What's that?
All the wildlife inside the canyon just kind of...
I don't think it drowns them because they probably have an opportunity to walk away from the water. You know, the water fills pretty gradually. There's like spiders in a bathtub. As long as they have a way to walk out, they're going to get out of there.
But most of the ecosystem.
Yeah, but you do. That's a break in the river ecosystem. You got river down below and river up above, but there's a giant lake in the middle separated by an artificial cliff.
Is there always water flowing through them?
Yeah,
So do animals like fish and stuff get like?
sometimes. Yeah. Now look, that water can be released through the turbines to make electricity or through the diversion canals to just manage your water level. You don't want the water to spill over the top of the reservoir. That causes erosion and would break it. So, unless you're trying to build up water volume, once you get to the mostly full level, all the water has to be leaving one way or another, either through the turbines, you see those little jets, or through the diversion canal, that's the bigger jet just beyond it. Yeah?
When they flooded it, would they open all of it?
When you flood it, they're all closed, so you
Or
fill in the reservoir.
There was in the reading packet today.
When they drain the sediment out,
Yeah.
you don't put the sediment through the turbines.
No, I figured, but I was wondering if they let it through the diversion canal.
Must be the only other way out, I think. It's either the diversion canals, which are also the overflow canals, or the turbine. And you can't put the sediment through the turbine, so it must be going through the canals. There may be a plan C that I don't know about, but I'm pretty sure that it's either diversion and overflow or turbines. Yeah?
Seems like they're wasting a lot of energy on the water from the diversion canal. Why not just put a turbine in there and then...
Well, because there's times when you got to get rid of the water to manage your water levels, but nobody needs to buy electricity. You see, these are businesses. They sell electricity. Why wear out the turbine and pay for the dudes that have to work at the turbine plant and clean those toilets for that staff, and if you don't need to sell the electricity? There's part of the year where the water's just not a valuable resource, and so they just flush it. There you have it. We have built a dam that holds a reservoir, use the intake to get the water through to the turbine, generates in the powerhouse to go to the grid, and returns water back to the river. We have a whole bunch of these. These are the big ones. There's actually 11, I believe, on the Colorado River now.
Are they even that efficient in generating electricity? Like, do they generate a lot of electricity and make it worth it?
Yeah, as electricity plants, they're one of the cheapest forms of electricity.
Are they? Because I remember in the Riverways movie, they were saying like it's not even that.
They were talking about the Columbia River there. On the Colorado, these are much larger, and so because they have a lot of fill height, the water squirts out really hard, so it can power a lot of turbines. When you have meandering rivers,
It varies per
it depends on the scale of the dam.
What are the purposes other than using it for energy and for using it as kind of a bridge as well?
I think as a bridge, it's probably the most expensive way, so that, I guess, that has to be irrelevant. You could build 1 million bridges for the price of a dam. So, 5 main reasons, and everybody has to know why we like dams. Electricity is probably number 1. Urban water supply, agricultural water supply. Usually, yeah, they're 2 separate things. Agricultural water supply is usually delivered by the river itself, while urban water supply is usually delivered by plumbing. Number 4 is flood control, and number 5 is recreation. As a side benefit, people like to go play there.
They like playing games.
Right or wrong?
The water slide there.
You know, like spring break, Lake Powell. Yeah, you know what I'm talking about. No.
That's like the mouth of like where the dam starts. Let's say the Hoover Dam. How deep is the water? Super deep. 450 feet. Well, did they dig it out? Like, did they?
480.
No, I mean, like, did they dig it out, or was it that deep just naturally?
Clog it so the water fills up to 480. The canyon is more than 500 feet deep. Now look, yeah.
So if you have your dam and then all the water funnels through here, instead of just putting like a single turbine can put like 15.
Usually it is a lot.
Times.
Yeah.
So it doesn't like at some point it starts being.
Oh, not in a row. But you see all these? These are all in parallel. Each of those is a turbine. So you see, you got to have really pressurized water. After it goes through one, it's used most of its energy to spin a turbine. There's no point trying to use it again. If there was any more energy potential left, you should have made a slightly bigger coil of wire or magnets to use up its energy. But you only get one shot at that energy potential. As the water drops those 400 feet, it speeds up a lot thanks to gravity. That's what you turn into rotation. You can spread that out over a bunch of turbines or make one giant turbine, but you don't want to put another one downriver of that because you've given up all of its energy potential. Now look, rivers have this crazy, dynamic nature, and dams are designed to do exactly the opposite. You build a dam so that you've got water when the river would be dry in summer. Yeah, and you build a dam to catch the water when the river would otherwise be flowing. You know, it's like a storage account. Instead of having all of it at once, you put it in savings for a while and then you spend it down for a while. So dams are designed to do the opposite of what rivers do in nature. And there's a key principle of AP Environmental Science that all of you must know. Please look up. In all the history of life, change has been a constant. You know this. The planet gets hotter, the planet gets colder, the forest gets drier, the forest gets wetter, and as long as that change is slow, wildlife can adapt. It's called natural selection, evolution, no big deal. The monkeys get smarter, the mammals spend more time in the ocean, and over many generations, very slowly, they become whales or something. The hippopotamus became a whale, something like a hippo. Change is fine. The problem is when you change things really quickly. When you put a fish that's evolved for 50-degree muddy water,
It's like a 5-minute build-up.
it was totally worth it. Look, you put a fish that's evolved from muddy water at 50 degrees into cold, clear water at 35 degrees, he's not going to make it. Those rapid changes are the problem. So what I want to talk about is problems with dams. And for the first time ever, I've come up with a new way to organize this. I'm going to try to make this a theme in my class. We'll discuss physical, then ecological, then human, like we did with canals. And we're going to break this up, comparing a dam to a river, uphill and downhill in each of these places. I just wrote up my notes for the first time in this way today. This is number 22. Impact of dams. This is definitely a 3-star one. Look, if that doesn't say 3 stars to you, I don't know what does. So first, the physical changes to a river. Uphill, it might seem obvious, but we're going to flood the canyon. We'll come back to why that's important. Number 2, uphill, in the reservoir, the water will evaporate. Most reservoirs evaporate as much as 50% of their water content. You know, look at me. If the river's like my neck down at the bottom of this canyon, that's shaded and sheltered, not a lot of evaporation. But if we raise the level of the water to the top of the canyon, now you get a lot of sunlight, now you get a lot of wind, and you're going to evaporate a lot of that water volume. So one of the big physical changes of a dam is uphill of the reservoir, you evaporate a lot of water. Number 3, uphill, you trap a lot of sediment. So the 3 physical changes, uphill of the dam, we're flooded the canyon, evaporating water in the reservoir, and trap sediment in the reservoir. Now downhill of the dam, you get elevated salt content, salinization, because you evaporate the water but you keep the salt. So downhill of dams you have salinization. Downhill of dams, you get colder and clearer water. It's more clear because you trap the sediment. It's more cold because it's a deeper body of water. So clearer and colder water.
So that's why like 7 falls is like bigger cool water.
Yeah, I mean, because it's pools, it's colder for sure. Everybody knows, right? When you swim down a hill in a pool, it gets colder. You're further from the sun. There's like all the sunlight is hitting the top, not the bottom. In the ocean, you find this. You paddle around up high as you go deeper, it gets colder. And the third change downhill of the dam is you've lost sediment because all the sediment was left uphill. Those were the physical changes, and they'll all be important to remember when we start to look at ecology. Now, ecologically, the biggest problem uphill is you have fragmented the habitat. There's a barrier to migration. You've broken up the river with a giant cliff and lake. So the biggest problem is uphill of the reservoir, you fragment the habitat relative to downhill. Now, downhill of the river, of the dam, this is a really long list. Number one, the fish can't hide anymore. You ever see people walking around downtown wearing camo, and they're like shopping at Urban Outfitters, and it's like, what's the camo for? It's not like you're hiding. You don't blend in. Say what?
Nobody wants to be seen in Urban Outfitters.
Okay, so it's a bad example. Thank you for pointing that out. But they're shopping at something, and the camo doesn't really work for camo if you're in the middle of downtown, is my point. Imagine being a brown fish that's used to a muddy river. Now you live in a clear water river, that camo doesn't work anymore. Does it make sense, everybody? The fish can't hide because the water's clear?
Same with the library, right?
Yeah, exactly. This is also true of everybody that depends on a muddy bottom, like bottom feeders and insect larvae. With the loss of a mud bottom, now they're getting tumbled by rocks and they may not be able to hide or bury themselves in the mud. Number three, as the water gets colder, some species just can't tolerate. I was talking about the mud bottom feeders and insects. Number three, that cold, as the water comes out colder, that's outside the tolerance of many species. Number four, without the sediment supply, you lose a lot of what's called riparian habitat. You know, the sides of the river no longer have the mud to build the riparian habitat. And number five, that saltier water, that salinization, that can be a really big problem for plants and amphibians. Any questions about ecological changes downhill of the dam? So now comes the human issues. First of all, humans lose land uphill. You know, in a lot of parts of the world, people might not even know that there's a reservoir being built. You heard that in the Narmada Valley in India. Many villagers didn't even realize that the flooding was permanent. So all of a sudden the river floods your house and it's like, wow, that's weird. This is really extreme flooding, and then tomorrow it just gets more flooding and everybody just moves out for a couple days, and then over a few days their houses are underwater. In the United States, it's not so bad. Usually the government will buy you out. If you don't want to sell your property, they take it from you anyway. But they give you money for it. You know, eminent domain. This is uphill. But imagine what it would mean if your family farm got flooded. If your grandfather's grave by that nice tree was now underwater. Some people still have attachments to the land. It could be worse. In other parts of the world, they wouldn't even tell you or they wouldn't even pay you. But a lot of people, you know, don't get to vote on this. It's just that their land is lost. Number two, archaeological resources are a really big deal near rivers. Keep in mind, there have always been people living along rivers. Here's a fun fact for you. In the world of underwater archaeology, American archaeologists trained in the 1970s are like the superstars, because a bunch of people who had research projects along the Colorado River, when they built Lake Powell, had to either give up their research projects or get scuba certified to finish the project as the reservoir flooded their archaeological site. So our American archaeologists helped develop the most well-known methods of underwater archaeology that's really useful in like Greece and Rome now, because so many of our archaeological sites in the United States were flooded by dams in the Colorado. Yeah, you know, people have always needed water. 3,000 years ago, there wasn't like easy plumbing and stuff, so people just lived along the river. Any place you build a dam, whether you're talking the Nile, people lived along the river. You're talking the Amazon, people lived along the river. So there's always human artifacts near water. And that's a big issue when you flood reservoirs. Now, probably the single biggest problem for humans uphill of the dam is that the dams just don't last very long. As an investment, they turn out to be a pretty stupid investment. We always thought hydroelectric power forever. So whatever the cost, you know, it's free electricity forever. Now that we realize that dams get full of sediment, it's actually not a very good investment anymore. Really large-scale dams are kind of, nobody really does that anymore. I don't think anybody's going to build large-scale dams globally in your lifetime. The economics just don't work anymore, because they're increasingly expensive to build, and knowing that they don't last very long, and then they're really expensive to take apart, it's like a nuclear power plant. It's like the problems are just not worth the cheap energy anymore. Downhill of the dam, we've got 4 problems, and then we're done with this list. Sediment blockage accelerates subsidence. Remember how like New Orleans is sinking because the water is washing away the ground? With no sediment being added, some areas are subsiding more quickly because all the sediment is kept in the dam. Number 2, that also removes a nutrient supply for farmers. The same way that wetlands fill up with really good dirt, farms along rivers get really good dirt from the sediment supply. Without sediment supply, those farms have lost a primary nutrient source. Number 3, dams really hurt fishing. They mess up your salmon. In the rivers where you have salmon, which is not all rivers, by the way, but even if it's not salmon, like in the Sea of Cortez, no salmon, but the chemistry of the water changes. The sediment supply changes, the salinity changes, the water volume changes, the water timing changes. So this has really big impact on ocean fisheries. Finally, in many cases, dams create really sticky international issues. I believe Mexico had to sue the United States because we were hogging so much of the Colorado River water that we weren't giving Mexico the volume of water that they were due by a legal treaty. So they sued us and won to force the United States to release more water across the border of Mexico. Egypt, I can't remember which country, almost came to war with one of its neighbors over water because of the dam. Okay. Anybody want to talk more about impacts of dams? Good news. Little ones are possible to take apart. Bad news, we have no way to take down our big dams. And they're a ticking time bomb. When they get full of sediment, they'll rupture. To put it in perspective, Glen Canyon Dam receives 2 dump trucks worth of silt every second. 20,000 dump trucks of silt a day. 10 million tons a year. And they've done that for 50 or 60 years. How are you going to get rid of all that sediment? Where are you going to put it? You know where all the sand in the ocean comes from? Land via rivers. When you clog the rivers, you just have all the ocean sand in your reservoir. Now what are you going to do with it? Yeah?
Is there a timeline for any rupture?
Well, it's less than 100 years for sure.
And it's like, gonna happen.
You know, right now there's no solution. It's not going to happen, but if we keep going like we're going now, yeah, it's going to happen. They are building up sediment much faster than you can flush the sediment. You know, if you let it out of Hoover, it goes into Glen. Right? So you can, like, solve this problem by making this problem worse. People are talking about draining the bottom one, then blowing it up, draining the second, then blowing it up, then draining the third, then blowing it up. But the time scale wouldn't reach the upper dams by the time that they overflowed. There is truly, like, it's not like it's a mystery how to get rid of the dam. They're pretty fragile. You know, the little dynamite, it's not like, the trick is not breaking the dam. It's doing it in a managed manner so you don't get a tidal wave of water with a tidal wave of mud in it. You know, people live along those rivers. People depend on that electricity and water. And there is currently no reasonable plan to solve this problem before it blows up.
We had no resolution when we were just going to build dams and then we were going to deal with it later.
Apparently, nobody anticipated the rate of sediment loading.
You think we'll just wait for like a really bad drought year where the river is not very full and then...
Yeah, I don't know. I mean, I can't answer this. I have no idea. I could probably be a really rich man if I could solve this problem. I really don't know. So globally, most countries have learned their lesson, and they look at the United States and they go, we're not building those stupid dams. Except for number 23, everybody make fun of China. China built the world's largest dam recently. It's called the Three Gorges Dam. We only have about 4 minutes left of this class, so I'll try to give you some of the funny stuff. China wanted to provide more electricity. So when they built the plant, they said, this thing will give us as much electricity as 18 coal-burning power plants. At the time, that was 10% of China's electricity budget. So they said, whatever the cost to get 10% of our electricity, this is a good idea. They planned the world's largest dam. It's 1.4 miles across, 61 stories tall. It is the largest thing ever built, the most expensive thing ever built, the most concrete ever used, and the most workers that ever went into one project. It's the largest reservoir on the planet, 410 miles long. It takes as much as 6 or 8 hours to drive all the way around it. It's the most concrete ever used for any project. Did I already say that? It's the largest electricity producer on the planet. It makes about 6 or 8 times Hoover Dam's electricity supply.
Do you have any pictures of it?
I don't have any pictures, but you can find them on the internet. Now, here's the funny thing. It probably cost in the ballpark of $24 billion by the time they got it finished. the price doubled, then doubled, then doubled. So all the investors dropped out, but China was already in, so they had to keep going. They figured out it wasn't going to be as much electricity as they thought because their electrical demand grew. So today it makes up less than 3% of China's electricity supply. Now it's not really that worth it. And they did not anticipate the amount of pollution that would accumulate, because when you flood all those cities, there was a lot of unmapped waste that's now part of the reservoir. They also didn't anticipate an increase in erosion, because when you start to get mud at the bottom of a cliff, that slides and causes erosion above it. So it's extremely polluted. We'll never get the right number because China doesn't like to report these things very honestly and clearly, but we're somewhere in between 1 and 2 million people displaced from their homes. Apparently there's like parts of the reservoir where people are still like free diving down to their homes to get stuff out as the water level rises. They have found radioactive waste, sewage, dead bodies, trees and houses all building up against the back of the dam. So they had to invent a new method of waste disposal. There's like a conveyor belt on a pier that sinks into the water and moves. It's called the tongue. And it laps up floating garbage onto trucks that drive it to a new landfill. Essentially, the reservoir is a way to take all the garbage from upriver, float it to the dam, and now they lap it up with a mechanical tongue to put it into a new landfill. Well, I don't know. I mean, getting rid of the garbage is probably good. Now, one of the big reasons for building this is it's in a really major flood river. The Yangtze River floods really aggressively. Historically, it was a very dangerous river. So everybody got excited about the flood control until they realized the final punchline, it's built on top of an earthquake fault.
Be nice and funny one day.
Goodbye, children.
I thought China was smart.